All right, let's dive right into this explainer on Claude Code's dynamic workflows. This is a feature that completely fundamentally changes how we as developers can tackle massive tasks, but only if you actually know how to control it. We're going to explore exactly what happens when an AI model graduates from just answering your questions to actively orchestrating its own sprawling multi-agent development teams.
Now, you know the feeling, right? We've all faced this core frustration. You ask an AI to do a massive code-based sweep, maybe a security review across, say, 50 files. It checks the first 35, builds up all this massive context, gets lazy, suddenly drops your original constraints, and falsely claims the job is totally done. It leaves those last 15 files completely untouched. And of course, you only find out later when a bug ships from a file the AI swore it reviewed.
But when you finally solve this context limitation, you unlock absolute superpowers. Just look at the bun runtime as an example. By utilizing dynamic workflows, developer Jared Sumner ported the 750,000-line bun runtime from Zig to Rust in just 11 days. Think about that scale for a second. It didn't just get ported, it achieved a 99.8% test pass rate right from the very first commit to merge. I mean, that is the sheer mind-boggling scale we are talking about here.
So to get you using this effectively, here is our roadmap for today. 1. The single context problem. 2. Enter dynamic workflows. 3. Under the hood. 4. The hidden token costs. And 5. Choosing the right tool.
Let's kick things off with Section 1, the single context problem. We really need to understand why single prompt coding just completely breaks down at scale.
When you push a standard AI context window with long-running, parallel, or adversarial coding tasks, you basically hit 3 massive roadblocks. First up, context limits. The window fills up and work is just skipped. Poof, gone. Second is self-review bias. If you ask a single session that just wrote code to check its own work, it is heavily biased to say it did a phenomenal job. It's literally grading its own homework. And third is goal drift. As conversations get super long, the AI uses lossy compaction, basically a summarization process that slowly erodes your original edge case constraints. It's like playing a giant game of telephone with your own code. Which brings us to Section 2, enter dynamic workflows, and how we actually escape that single context trap. To combat those exact failures, Anthropic introduced dynamic workflows in Claude Opus 4.8 and then supercharged them in Opus 5. The secret sauce here is something called a harness. Instead of relying on some static, generic setup, Claude actually acts as a master orchestrator. It writes a custom-built harness on the fly, tailored perfectly to your specific task. This program spreads the workload across multiple isolated subagents, giving each one a clean, highly focused context window. So, how do you actually kick this off? Well, it's pretty seamless. You can trigger it just by typing something like use a workflow directly in your prompt, or you can use the Ultra Code keyword setting. And when you pair that with auto mode, wow, Claude can autonomously spawn dozens or even hundreds of subagents to hunt down bugs or migrate code, and it doesn't constantly stop to ask for your permission on every single step. Moving right along to Section 3, under the hood. Let's peel back the layers and demystify the AI magic happening on your machine.
Because, it's not actually magic. A dynamic workflow is literally just a JavaScript file that Claude writes and executes in real time. First, it declares a metadata block. Then it uses top-level await commands to spawn parallel worker agents using agent and pipeline calls. And finally, it synthesizes all those intermediate results together. It cleans it all up so that only the pristine, perfectly verified final answer actually hits your main context window. And man, Claude Opus 5 completely supercharges this whole architecture. Opus 5 defaults to deep reasoning or thinking right out of the box, and it rocks a massive 1 million token context window. In practice, this means the orchestrator makes incredibly intelligent decisions at runtime. It evaluates scope, delegates, and verifies its own work way more aggressively, totally hands-free. But, and this is a big but, we have to talk about Section 4, the hidden token costs. This is the danger of just letting Claude figure it all out on its own.
This incredible flexibility comes with a trap that catches so many technical project managers totally off guard. As the folks at Mind Studio pointed out, because Claude is autonomously reasoning about its next steps rather than following a strict script, mistakes don't stop the clock. If a subagent hits an error, Claude might try to work around it, try a new tool, reason about the failure, retry, and the meter is always running. That compounding context burns through tokens incredibly fast. To put that into perspective, if you fire up a large run deploying 100 subagents and each one eats up around 5,000 tokens, you are easily looking at a 500,000 token burn for a single workflow execution. This is exactly why you have to budget carefully. You can set size guidelines, like restricting it to small for under 5 agents or large for under 50. You can even explicitly prompt Claude with a hard budget, like use 10K tokens, just to keep those exploratory runs from sprawling completely out of control.
So, knowing those steep costs leads us directly into our final part, Section 5, choosing the right tool. Let's build a pragmatic decision framework. You really don't need a massive dynamic workflow for every single task. Reserve fully dynamic workflows for the absolute beasts, massive parallel tasks like complete code-based migrations or totally unpredictable audits where you want unattended scaling. But if you're doing exploratory coding and need to stay in the loop, rely on the /goal command. With /goal, it's a supervised session-bound loop, perfect for when you want to review and redirect the AI mid-task.
And then there's a fantastic middle ground, static sub-agents. For tasks with identifiable steps that you run all the time, say a pipeline that goes from research to drafting to formatting, this is your sweet spot. You get cleaner failure isolation, smaller context limits per agent, and highly predictable token usage. You get the benefits without the massive overhead of the AI dynamically overthinking its orchestration on every single step. So before you just blindly fire off ultra code for your next ticket, you really need to ask yourself, does this job truly demand unpredictable autonomous branching, or is a structured pipeline all you really need? Ultimately, you have to decide, is your next deployment going to be a masterclass in AI orchestration or just an expensive lesson in token burn?